Hello, welcome back. Before starting the next lecture, I would once again thanks Professor Oliver to taking us to the world of nanotechnology, which is the most renowned one, and we even having a bit and piece of knowledge. I thank Professor Oliver. Now, I would request our chairman, Dr. Khalid Muhammad Abdul Wahad, the Dean of Faculty of Medicine, to introduce our next guest of honor, Dr. Bakit Al-Rashidi, a material engineer from Dayton University, Ohio, USA.
بسم الله الرحمن الرحيم والصلاة والسلام على أشرف الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. We are going to start our second session today, and our speaker, Dr. Bakit Al-Rashidi, who is a nanomaterial engineering PhD from the Dayton University in America. He's an expert in the detection of porous materials, futures, nanotechnology. He got the award for the Saudi Arabia Cultural Mission in Washington for the advancement of science, 2010 and 2011. He is a representative of the American University of Dayton in the Gulf Cooperation Council and Qatar Foundation Research. He was the chairman of the Committee of the Student Advice and Guidance in Washington in Saudi Arabia Culturate. He is a member of the American Chemical Society, and he is a member of the Organization of the International Carbon Society. He got the Dean's List Award for the University of Western Illinois. He's an expert of several courses in maintenance, chromatography, appliance for chemical analysis and detection of chemical compounds, future, nanotechnology, and painting and drawing chemical compounds. Dr. Bakit, he's going to talk about carbon nanotube and storage energy applications. Doctor, start.
Assalamu alaikum wa rahmatullahi wa barakatuh. Thank you, Dr. Khalid Al-Abdul Wahab, for introducing me. Today, it's my pleasure to talk about carbon nanotube and storage energy. First of all, I'm trying to take from large picture of nano to small angle in nano. You can say from large picture to nano place in the nanotechnology. Actually, exactly when you talk about nanotechnology, you think about scale. I'm working about scale. That means I have matter, I change the matter size of these particles to get more benefit, advantage to apply in our application or in our any industrial field. When I say carbon nanotube and storage energy application, that means I will use one scale, is called nano scale. Exactly, I want to use carbon form size. This is my outline for today. First of all, I will give an introduction about nanotechnology and the history of material engineering. After that, I will go to explain about the challenges and properties in the same time in carbon nanotube, what I need to use in my application for today. Second, motivation. I have one application. I will explain this application, which is carbon nanotube, use it for storage energy. If you want to try to storage energy, first of all, you have to think about the problem issue in the world. As you know, the protection of the energy is easy from petroleum, solar, we have many cases. But a few of people think about how can we storage energy. Either if you want to storage energy or convert this energy to other case. If you want it exactly to storage energy, you have two cases, battery or capacitor. but I'm focused on capacitor. After that, I want to check all the parameters of capacitor from this side and design of capacitor to create a new capacitor. I'm not the first one to create a supercapacitor, but we have many people before me, they took many a design. So I'm working with two things. I have design approach and I have theoretical approach. So to optimize these two design, I have to mix it together. I will get cocktail. This cocktail succeed my project. And also, I have to bring theoretical parameters to narrow me which parameter I use to modify it and to improve my sample to get more better result for this work. Then, after that, I have to prove my work for the people. I use something is called characterization tools. In this work, I have 3 types of characterization tools. I have SEM, what is called scan electron microscopy. After that, I will use AFM and Raman microscopy, and I will calculate my sample result. This is called material engineering through history. When you try to start the life in the beginning, the man made his tools from stone. They start stone age. After that, he thinking to change his tool by using bronze tools, would have spear and helmet here. After that, he thinking about iron age. But when the man thinking about he changed his tools. But currently, we are in the age of silicon, plastic, ceramic, carbon, age of composite. A standard of living in any civilization, heavily linked to developing and use for new material. That means we need new material, you have to change what we are using. So, everyone know nano is a scale. This is what I mentioned when I start my presentation. But in my opinion, the nano, the key of the technology for multifunctional materials to create new materials to use it in different applications. What is nanotechnology? What that mean? Create useful functional materials, device, system through control, millimeters to get a good or perfect properties. Like that's mean I use any useful size to change this. To change these properties and phenomena, physical and chemical and electrical and mechanical and optical and magnetic. So I will try to give a short brief about nanometer. 1 billionth of meter. The hydrogen atom, the size is 0.04 nanometer. The protein between 1 to 20 nanometer. Also, what mentioned Dr. Oliver about the computer chip, we are working in this scale since 2005. By the way, the human hair, the size is around 10 micrometer. That means we are working in less the size of the hair human. Nanotechnology, what that mean? What you are looking? Apple research and technology developing to get, understand and control matter dimension for nanoscale, nanometer and nanoscale. Ability to understand and create the use structure, device and system, fundamental new properties. What I mentioned also, physical properties or chemical and etc. Also ability to imagine, measure and thinking about how look like the particles inside. Also ability to integrate those properties and functional. Like we have here the scale of nanotube. Here is kind of double wall of carbon tube. As you know, the carbon nanotube, you have single nanotube, which I have sheet, for example. I can consider this way. If I have graphite sheet, I try to change the dimension. I will give single carbon nanotube. When I put other one, I have multiple carbon nanotube. Why I'm focused on carbon. When I talk about material engineering history, we saw age of silicon. The people think about what above in the periodic table, above the silicon, carbon. They found something related to silicon. And as you know, the carbon is cheap. These important things. Also, it can go in different ways. Semiconductor. Besides that, he have ability to connect to many elements. As you know, the shape of the carbon, tetrahedral and covalent compound. Also, if you say in our life, I don't like to say 75% of our life from organic compound. That means the main element in our life is carbon. Here, I give small definition about carbon nanotube. It's general, not specific. Carbon nanotube, cylinder carbon molecule with novel property, and then potential useful in the wide variety application. Nanotube are composite entry sp2 hybrid bound similar to graphite. If you go here, if you see what I put here, how comes diamond is so hard and graphene is so soft? The difference only the size of angle and the hybridization. The diamond is sp3 and the graphite is sp2. This is the important history about carbon nanotube. In 1991, Ultima discovered multiple carbon nanotube. I don't like to go in all this history, but I'm focused in first and beginning. In 2001, the people thinking about the superconductivity. I mean, this is very important. That means I have something is semiconductor and converted to be conductor. What we will do, what we will see, what we think. That means many research, it's come in this area. I try to mention some carbon nanotube properties. It's strong and flexible, and it's very important. You know, the Young modulus is over 1 tetrapascal versus aluminum is 70. That means the carbon nanotube more strong than the aluminum. Do you think aluminum is more strong? That means I can use it in many applications in medical field. Also, the strength of the weight is 5 times of the aluminum. Also, is higher than any materials. This is important key for me. I will start from this area. Thermal conductivity. Right now in Saudi Arabia, we have Aramco company and Sabic company. They thinking about carbon nanotube to remove one important issue. How can remove the heat from pipeline and the heat from the engine? Also, my project in this today is electrical conductivity higher than copper. As you know, the people take the copper and sell it in the market. What do you think when they know about carbon nanotube? It's more have electrical conductivity. Also can be metallic, semiconductor I mentioned before. Also depending on sterility. That means when I change the dimension, I will get something useful. The carbon nanotube have electronic properties. Dr. Oliver, he mentioned in his presentation. And we have also magnetic field. Also, Dr. Oliver mentioned mechanical deformation. Also, we have other chemical group can be attached to carbon nanotube. That means we can put or doping or coating the carbon for different material. This is, a short form about some application for carbon nanotube. CNT quantum, wire, diode, transistor, data storage, capacitor, flat plane, also sensor, bio, sensor, DNA, they can detect the DNA structure by nanofield. Also, we have use it in muscles. Besides, we can use it in the flight or aircraft area. We have challenges for CNT. When Dr. Oliver, he said, we don't have how can apply more carbon nanotube in one ship or billion thousand. That's been difficult to control it. It's very small. Also, we have contact issue because if you convert it to conductor, be careful about contact issue. Besides that, it's very expensive to develop this part research. As some question Dr. Raed, he asked about what do you think to start to establish that? In my opinion, we are just research and develop. This is the industrial field. Who thinking about sell the product, he have more instrumental to give him that technology and to sell them the technology. After that, they thinking about how to develop these items. Now, this is my motivation for this application, carbon nanotube and storage energy. As I told you here, we have problem around energy in the world. The people, they thinking about how produce the energy, but no one how thinking about storage the energy. We are thinking about storage energy. We have two cases, as I mentioned before in my outline, battery or capacitor. Also, I will make compare between them and what we are thinking about it. I make small compare between battery and capacitor. As you know, the method of charge storage in the battery, chemical energy release and through reduction and oxidation. The capacitor only in the surface of electrode exchange the ions. Also, the energy density is very high in batteries, but it's very low in capacitor. Power density also is very important. Storage energy is low in the battery, but it's very high in capacitor. The life cycle, which means how many times I use this item, in battery is very low. And in capacitor is amazing number. What I'm thinking, we're thinking about to take advantage from each and try to avoid disadvantage. We create something is supercapacitor. This is I will explain how we're thinking about the design. It's very important for us to design to get the goals. What's meaning supercapacitor? Is intermediate position between battery and capacitor for energy density and power release. Fast charger and discharger. Oops. Also could be used alone or it could be connect to other advice. I can use the supercapacitor to storage energy from wind turbine. You know everyone the wind turbine. Also, I can use the supercapacitor to storage the energies come from solar. Also, I can connect supercapacitor with battery to avoid the problem. This is what many things about the company who make the biomedical items, they think. For example, if I'm during the surgery and I don't have power, what will happen? We have something to come the power for us, which use the battery beside supercapacitor. Supercapacitor, exactly, we are playing in the surface of electrode. When I have the surface of electrode, I'm trying to see how many ions or particles, nanoparticles, come to exchange with the surface of electrode. That's mean, in simple equation, the capacitor, how can measure the value of capacitor? here. We have S, that's mean surface area, and the distance between the separator charge. That's mean when to increase the capacitance, if you increase surface area, and same time decrease the size between the two electrode. I will explain exactly what's meaning electrode, what's meaning the surface for this item. This is the design of many items discovered in the past. Let me give something about what consists of supercapacitor. Mr. Beaker, in 1957, he created the first supercapacitor. 2 electrode, 1 jar, that's mean beaker, and connect each other and put solution. It's called a liquid electrolyte from sulfuric acid. And when he measured his supercapacitor, he found only 6 Faraday per gram. After that, Reitmeier in 1962, he thinking how can apply or can mammonize the size of supercapacitor and avoid the leaking issue by take many layer and put between them gel like electrode and more concentration, and he got only 80 Faraday per gram. After that, many type of supercapacitor found in the world, micro supercapacitor, integral. The Dr. Shane, he reached around 160 Faraday per gram, and also we have different form for micro supercapacitor, sand switch, and roll it up. Okay, so now we know the basic of supercapacitor, 2 electrode. Okay, the size, we don't have any doubt to change the size of the surface electrode, but we try to thinking, as I show the equation, increase the surface area. We have 3 stages in this supercapacitor industry. First stage, they use carbon fiber, carbon alloys, activate carbon. After that, they're thinking about metallic oxide. That means they're using polymer and the surface of the electrode to improve the capacitance. And the third stage, they combined stage 1 and stage 2 to get more benefit. That means, for example, I will use carbon nanotube with band polymer, mix it together, or different materials, and get more. Several way we have to get high capacitance. So my choice for this application, I'm using carbon material. I will explain why I'm using carbon material exactly. Also, the surface of carbon based on composite material, which resin, it can change physically or chemically to improve the contact between the layer I put it in the surface of electrode and the liquid electrolyte. Objective for this work, to create carbon-based system. That means I'm taking advantage from stage 1, and for freeze type, that means I have high energy, high power, long life cycle, not toxic, 100% is carbon, high surface area. I will explain from where come surface area. I convert the carbon to conductive material. Also consists continue work. So I decide to use in the surface of electrode activate carbon. Okay, the general idea about activated carbon, that means I'm taking the carbon, I make 3 thermal treatment to get activated carbon. Okay, high surface area, storage more energy, but is low electrical conductivity. This is a problem. Then your project is not working very well. You got wrong here. We have to create this, you have to thinking about something to solve this problem. We're thinking about using carbon nanotube to get higher higher electric conductivity, also to get high surface area. By the way, if you imagine this area, if I have surface of electrode, and say I have here separator between them, and I have other side of electrode, I didn't change anything. My hand is like this, but I applied carbon nanotube. That means I increased the surface area, but I didn't change the distance between two electrodes. As I mentioned, I have to find some way. I have different parameters. I have distance between electrodes. I have the porous of the molecule, the particle, and surface of electrode. I have to bring theoretical system, to optimize all of these factors. We bring this word design of gray system. What's mean gray system? It's come from gray color. I have white color, I have another hand black color, I mix it together, I get gray. But in the fact, when we call this system as a gray system, we think about white, that means I can't see anything. I know all inputs. But when I say black system, I don't know, but I have output, but I don't know what's happened inside. When I mix it together, I will get gray system. And this gray system, I will consult it in my experiment is super capacitor. So this is the equation. I use it for this experimental. I have 4 inputs. As told you, is the 4 inputs is called the gray system. I use the fiber to mix it with the carbon nanotube. I have activated carbon. I have activation time. Activation time, that means the thermal process, the thermal treatment I use it for this experiment. I make my calculation. I use all the factors I mentioned. When you see the gamma here 61. That means you have to, in your sample, you have to have more activated carbon. And if you see here 28, that means when you increase the activated carbon, you will find you have low activation time. Low, you are using the thermal treatment. That means I will increase in my sample activate carbon and carbon nanotube, and I will decrease the fiber. The related of all of these, the decrease of time. Let's say the statement from here, increase activating carbon and carbon nanotube, reduce carbon fiber and activation time. I will see this right or wrong. I put all the data I got it, my experiment, my reading of capacitance for different, usually I applied around 3,000 small supercapacitor. I get read from them and my data. This is the result I got. When I take the fiber and put on it, carbon nanotube is called growth. Carbon nanotube, I put only 30%. I got, during I make the thermal treatment, the activation time, 300 minutes, I got around 500. When I increase the carbon nanotube, what happened for activation time? Decrease. And same thing in range, the capacitance value. Also, when I increase more carbon nanotube, the time still increasing for activation. It's very important in our life or in our experiment. Also, we are increasing the capacitance in the same time. This is the carbon nanotube growth in carbon fiber in different length of path. I use scan electron microscopy to take these pictures. I have very short band, short length, and here I have medium and very thin. If you see the carbon nanotube around the fiber here. How make the electrode fabrication? I take polymer. You have to make your resin or polymer is homogeneous. Why? To make sure go inside and prevent inside your sample. I have 2 samples here, fiber and carbon nanotube. This is fiber with band, which is polymer, polyacrylonitrile. I have here carbon nanotube and growth on it, fiber growth in it, CNT and band. It's called a new thing, a new name, fuzzy fabric. This is the experimental step for for thermal treatment. I put my sample in this furnace tube here exactly, in this area. I put it for 20 hours under 150 Celsius degree, and I introduce the air. It's called stabilization. Why we call it stabilization? Because make cross-link and leader to the to polymer inside my sample, also to prevent from unwanted reaction. After that, I take the same sample, the same oven, but I change the gas, the type of the gas I'm using here, argon, for 8 hours under 850 Celsius. The third step to get activate carbon, I called it activation time under 800 Celsius degree. I use carbon dioxide to create a porosity. Why porosity? This is the first time I mentioned porosity. To make sure I have suitable and subtle size to ion go inside to react between surface of electrode and liquid electrolyte. For that reason, to store energy between liquid electrolyte and the surface of electrode. This, the type of electrode I made it, two plate of titanium, and this is my samples, and fiberglass as separator. I connect 2 wires and put them in CHI instrumental, which is for test the capacitance for me after calculation. I have sample. I fabricate my sample. I want to see the result of this sample. I have to go in characterization tool. I'm using SEM, scan electron microscopy, to get information about surface morphology. I get Raman to say composite of the sample is crystalline or amorphous. Also, I'm going to use cyclic voltmeter and discharge meter to know the value of capacitance I have. Also, I'm using BET measurement exactly to see how many surface area I have. BET is short form from the three guys who create this instrument. This is my sample under SEM. This is only carbon fiber, nothing on it. This is carbon nanotube with fiber. This is SEM. I work on it in UDRI. This is my sample after put the polymer to make sure I have polymer, I have my substrate. Also, this is inside of the sample to make sure I know the polymer go inside the sample. Also, this is the result of Raman spectroscopy to see here I have sample, nothing happened, and this one, that means something changed here. The morphology is changed. I calculate my capacitance. I have simple equation. Everyone here know it from chemistry department or physics department. Right now, I will show my result and discuss my result. I have 3 kinds of sample: fiber with polymer. I have fiber with polymer also. I have fiber with polymer. But the difference between all these samples, only activation time, only the last step of thermal treatment. Here, if you see when I call 0 hour, that means just I take the sample without thermal treatment. I have very small area. When I increase the activation time, increase the area, also when I increase. If you check the charge discharge, also that means we are improving the capacitance here. This is called, this graph, cyclic voltmeter, and this one charge discharge graph. I go to the other side. I get the carbon nanotube that is called fuzzy fabric carbon nanotube, fiber, and band for no treatment, 0 activation, 1 hour, 2 hours. Also, we have increase. That means my system is working. Also, we applied just charge discharge here. Same thing to prove my cyclic voltmeter graph. After that, this is my goals in this project. To provide the surface area to store energy. If you see, I choose the best result I reach. 4 hours, fiber, band only. 4 hours, fiber, band, carbon nanotube. I get height. I will see the surface area for my samples is increased or not. This is fiber and band with 1 hour is below 20 gram per meter per square. And when I check fiber with band 4 hours is increased. 1 hour fuzzy fabric, which is mean fiber and CNT and band, is polyurethane. I found increasing. When I use the last time activation I use it is 4 hours, I reach around 1800, something amazing number in the surface area. This is to check my supercapacitor is working or not after resistance issue. I apply capacitance graph between capacitance and scan rate. I found the highest value I have for 4 hours, the fuzzy fabric. Also, if someone asks me why not increase more than 4 hours for your project, already I increase. I have increased until 5 and decrease. Why decrease? Because the size of porosity, of pores of mercury, is more wider and is leaking the ions from it and cannot be stored more energy. Here also the fuzzy, same phenomena, I guess. My conclusion for this speech or this presentation: carbon nanotube based on supercapacitor give you imagine to storage more energy. Carbon nanotube improve the capacitance of the activated carbon and combined and optimize the carbon nanotube and ratio is very important to thinking about different way, different path in your future if you want to make research. This is what's called recommendation. I will mention also. I bring a great system method to show the key influence of the carbon nanotube and need to decrease the activation. We get this result. We need to decrease the activation time to get higher capacitance. Also, I'm thinking, what is this? My next plan to remove liquid electrolyte to use solid electrolyte. A few people research in the world talk about this area. Why? Because I'm trying to take this project to more safety to avoid the leak of liquid electrolyte. My conclusion, carbon nanotube, different use it. We can use it as a film, biotechnology. We are here, energy storage. Also, we can use it for coating. We prove that by using band polymer. Also, microelectronics. We have good speaker today about it. We also is the carbon system, not toxic, is friendly for environmental. Also, we can use it for filter. Right now, in the United States, they use carbon nanotube as one layer of water filtration to take or decrease the salt in the water. Also, transistor, they mentioned that. Biosensor, also we have good plan here to work in this biosensor and modified the CNT, the mechanism of biosensor. Also can use it in screen, and I saw last week good news in Stanford University. They try to make computer from carbon nanotube. I know you mentioned. My recommendation for this work, we have many ways to work and establish research. We can measure the flow rate during Front's tube to get what the result, maybe increase the capacitance. Also, we can investigate the change of ratio, the CNT, I forget to tell you that I use only 30%. I start. I want to check decrease less than 30%. I didn't make any study for that. Also, I'm trying to use different CNT with the solid electrolyte. Besides that, I want to see exactly the effect of different porous structure and porous size distribution for electro performance of solid electrolyte. Thank you for your attention and welcome for any questions.
Thank you, Dr. Bakhit, for this nice talk. And now the floor is open for discussion. We'll have about 15 minutes for that. Yeah. Can we have the mic here?
Can I get my question first?
Sorry. Yeah.
First, I would like to thank you for nice lectures. About the coating for the carbon, you told us about what is the advantages and what is the useful for that, but you don't tell us what is the side effect or what is the wrong or what is the things that make the coating in the wrong wrong result
Right.
or something like that. Can you tell us, please?
Yeah. Actually, before thinking about to make coating, you have to see each polymer, what the side effect for this polymer. For example, in this work, when you take band, we know only the one things from this band. To change this sample from semiconductor to conductor. That's mean before go to the coating, you have to study the type of the polymer you are using. Also, as you know, each polymer they discovered, they mention about the side effect. This is what you thinking. This is, I think, your answer about side effect. I can't hear you. No. Right correction? I told you, I have to study the properties of the polymer. I use it before I make coating. For example, the band, we know exactly. For example, when I use it, the band as heterogeneous solution, what will happen? Decrease the electrical conductivity and damage your samples, and you will be bulk, porous. That means it's not useful for your stuff. I told you before to say this one, you have to think. Also, besides that, before I choose the band, I read between 20 to 25 articles about band. After that, I decide to coat my sample.
When you choose it, what is the wrong also? After you find out this, you choose it, what is the disadvantage?
Advantage or disadvantage?
Disadvantage.
Okay. Disadvantage for my work, this work, you mean? I didn't find any disadvantage because I'm using characterization tool to avoid me about this one. Why then you use characterization tool? Let's us to make deal in this questions. For example, I have cell, I have coating, okay? Before I apply the cells, I have to study what kind of cell I have. What the sensitive things for this cell, okay? I put it in one side, I go to see the properties of the coating. What the benefit, what the advantage, what disadvantage for the coating. If I have similarity between two of them, I start the coating. Yes. Yeah, but I cannot work in this project. For example, I want a cell to apply my mind. No, I have to bring someone to work with the team to find the good eye.
Okay. Can you have the question there?
Yes. Okay, it's a nice talk and a very fine application. I missed to know what type of carbon nanotube you are using. For example, it's a single wall carbon nanotube or multi-wall carbon nanotube. And second one, that is you are using liquid phase of that nanotubes. So there is a random position of these nanotube. So is there is any study that if you use some preferable...
Excuse me, can you let the mic?
Oh, okay.
Because I heard the first question, but the second no.
Second one is, can you have any idea that if we use the carbon nanotubes in some special position, for example, parallel to the electric field or anti-parallel to electric field, what will be the effect of your super capacitor?
Thank you. Actually, as you mentioned in the introduction of this lecture, the sterility of the carbon nanotube is very important for us. But in this application, I work in the UDRI, it's called fabrication unit. We have different team. When you take the carbon nanotube, each team, he work in one side. But in my opinion, you have to try first which side, which area, which dimension you need to change to get more result. This one, the second question. Can you remind me the first question?
First question is, you use the single wall carbon nanotube or multi-wall carbon?
I use multiple.
So how you know that one is a multi-wall? Because you have...
Because we bought it from the company already.
Okay.
Okay, we have another one question from the lady side, if it is ready.
Assalamu alaikum. My question is about the radiation. We know that the carbon isotopes radiate, so the heat will affect it. What is about radiation? Safety of radiation?
I answered this question, but in a different way. I can't measure the radius because I'm not interested to see the radius, because the sample, when I take the sample, I know the radius for my carbon nanotube. Also, I know all the... My focus only the size of the porous. And also, beside the size of porous, I have two choices. Just I want to see the surface area. When I increase the surface area, the size of the porous is suitable or not. How can I know the suitable? Only from the result of the capacitance. I know one of my team, he work exactly to measure only the size of the porous. It's called porosity of your particles.
Okay, we have one question here.
Assalamu alaikum warahmatullah.
Salam.
Let me first thank Dr. Bakhit for his good lecture. And as you present, your research is depend basically on the carbon nanotube.
Yes.
Now, and we are talking about power or electricity storage. So the application for long term, we need lots of carbon nanotubes. Is there, from your research awareness, is there a solution for producing big amounts of carbon nanotubes in order to be available for this type of vision of your research?
Actually, Dr. Alfar, he answered the same question, but in a different way. The challenge, how can apply million of the nanotube in one ship? We cannot. Maybe we need 10 years, 20 years to find this one research. Now we work in a small area. In my opinion, if I find any way to apply more carbon nanotube in one ship, that means I increase my surface area, I will discover new thing in our life. But in my research or my field, I didn't find any way to apply more. Because as you know, I use thermal treatment, that means some of carbon tube will be destroyed.
Okay. Yes, please.
Thanks, Dr. Bakhit, for this nice presentation and topics. I just have two small questions. The first one, you mentioned that the carbon is the friend of the environment and use it for filtration about salts and water filtration. Is there any other application of this carbon for medical field, in the medical field, like control of some diseases or prevention of the dust infection or
Yeah.
something like that.
Yeah.
Second question, I know you mentioned, but I'd like to know what is the difference between gray system, black system, and white system again. What is the main difference between these three systems? White, black, and the gray system. And thank you.
You're welcome. About first question, in the lab which I'm working on it right now, we have some team, they try to use the carbon nanotube in the fraction of the bone. Also, my goals for my team, actually we try to develop the medical instrumental or medical equipment to use it for a long time, to avoid the charge time. Because as you know, the battery take a long time to charge your items. But by using supercapacitor, we have less 500 times than the time used in the battery. This is the first question. The second question about gray system or gray system, white system, I have something, I know it, I have information. It's called input, white. But when I say black system, I don't know what's happening inside, but I have output. I get result, but I don't know. Then when I take the information, output is capacitance in my case, and I have input for fiber, carbon, nanotube, activation time, activated carbon. When I mix it together, all this information, I get the result, to try to find the mechanism how supercapacitor works. This is what I considered gray system. But I don't know what's happening inside. But this is also good plan to think about new path of research. Thank you.
Okay. Yes, please.
Assalamu alaikum. I want to
Salam.
just ask about this, I want to elaborate this Dr. Raid's question regarding the safety
Can you
aspects
raise
of
mic?
safety aspects of this nanotubes. Because once it was this field was in infancy in 2000s and 90s, people used that it will be of great help in the medical sciences. But what the problem this medical field is facing with nanotubes, once you are inserting some charged field inside the dynamic medical system, like cellular level or at the tissue level, there is a lot of oxidative stress being created inside the cells, and it is non-specifically activating the oxidative stress genes like NF-kappa B, one of the genes, which activates your thousands of genes, and non-specifically. So you don't want to activate them. You are using this for one purpose, but it is non-specifically activating many of your genes, which you don't want. And there are hundreds of studies regarding that. It has failed in the detection systems in the medical field. Can you throw some light on that? And is your system, by increasing the surface area in the nanotubes and using multivalent nanotubes, is any difference in that field? Or can this improve on that by non-specifically activating the oxidative stress genes in the cell unnecessarily, so that we will be specific on our application part?
Let me change your questions, okay?
Okay, sir.
In different way, if I understand your question or not. You said you have different cells, okay? And you want to treat only one cells. You don't like to bother others, yeah? Okay. Also, you need some, let me continue. You need some increased surface area in certain amount. Exactly. I put the chart here. If you want to stop in carbon nanotube, if I need around 500 gram per meter, I can use only 1 hour for activation my treatment. So the guy who worked in this field, he told me, okay, this is a problem. I need from you to create idea to give me this size of surface area. We're thinking about this one by change the time of activation or thermal. I put in my mind, I don't bother other cells or affect other cells.
For the same cell, even if you are using it, once you are inserting some charged field inside the cells or oxidative genes are automatically getting a response, activation signal because you are inserting some charge, and all proteins, most of the proteins, they have the amino acid motifs on their cell surface, so they are getting activated non-specifically, because charge is there, charge cannot be a specific way of activation of the cells. So it is non-specifically activating the oxidative genes in the cell. Like I told you, one of the examples is NF-kappa B nuclear regulator. In turn, when it goes into the nucleus, it activates hundreds of more genes. So this is based on charge only. You're talking about the capacitors.
I told you, my case all increase the surface area. I don't like, if you are thinking about the side, if it is what you think, side effect.
So my question is only that once you are changing one dimension of increasing the surface area in the nanotube, is it going to help us in giving the specificity, not activating the non-specifically like I gave you the example?
I can say yes, I can say no. Yes, for increase the surface area, but in the future, do you think this will be stable long time or not? I don't know.
In dynamic system, it will not be, surely.
No. This is the answer. Yes
Okay.
or no?
Okay, thank you, sir.
You're welcome.
Thank you. Do you have any other question from the? Okay.
Do you think the carbon nanotube could be used in medical field, like in dialysis machine, for example? Do you think there is a possibility of using like?
Yes. Yes. I saw two gentlemen. They work in same lab. I work on it. They try to use some disease inside the eye by put some carbon nanotube to remove something around immunology. Also, I told you about right now around, I say 15% in our lab, they focus on fraction the bone to use the carbon nanotube instead of the metal. We have many research in the, you can say UDRI, exactly if you put it in the Google, UDRI, our science direct UDRI fraction bone, you will find this one, exactly from the same lab. Also the guy who worked, his name Jerry Zimmerman, he's from Germany, he worked in this area. He used same the sample I use it.
Okay, I think we have to conclude here now. I would like to thank Dr. Bakhit for his presentation and the discussion. And I'd like also to thank the organizing committee for giving me the opportunity to lead this class. And I think we will have break and prayer, then we will come back for the last session. Thank you very much. الله يعافيك.